In my opinion, the best thing you can do to deal with missing data is to make your algorithm, machine learning algorithm, robust to missing data. In other words, make your machine learning algorithm adapt to missing data. And that's exactly what we're going to do in this particular module. And we're going to do it in the context of decision trees, because there's a simple modification to decision trees that can handle missing data. So, how we're going to deal with missing data? Let's try to understand a little better what happened in the context of decision trees. So I had this input xi where the credit was poor and the income was unknown. I go down the decision tree, I hit credit poor, so I take the branch here, poor, and then I hit income, but income was unknown. Income was question mark. So what do I do then? So what we're going to do is assign a branch to follow when the data is unknown, when the value is unknown. And in this case, I'm going to associate all unknown data, for example, with the branch where income was low. So if your income was unknown, take the branch low. And from then, I'm just going to predict that this loan was risky. So in other words, in our decision tree, we're going to make explicit decisions as to where question marks or missing values, unknown values will go. We've introduced a decision to what happens when we hit an unknown value at this point of the decision tree. But we might hit unknown values at any point of the decision tree. So we're going to make decisions everywhere as to what should happen when we see unknown values. So for every decision node, we're going to choose one of its branches to absorb the unknown values. And notice that those are going to be specific decisions we're going to make associated with every diamond node or every decision node in the decision tree. So for credit, we're going to have the unknowns or question marks go into the fair branch. For income, for when credit equals poor, and we look at income, we're going to go down the low branch. When credit equals poor and income is high, we look at term. And in this case, when term is equal to 5 years, we're going to put the unknowns or the question marks in the 5-year branch. However, take a note of this. We might choose to say that when credit equals fair and we look at term, the unknowns in this case will go to the term equals 3 years. So the decision that we make about where unknowns go does not need to be the same in different parts of the decision tree. So we take different decisions here about the question marks or unknowns. And that's the beauty of the approach that we're describing, because we're going to optimize, just like we optimize the structured decision trees, we're going to optimize where the unknowns will go in order to minimize the classification error. Now, if we learn a tree like this and we're given an input, for example, where the credit is unknown, the income was high, and the term was 5 years, we can go down the tree and traverse, well, the credit was unknown, the term was 5 years, so I'm going to predict it's a safe loan. While if I have another input where the credit is poor, the income is high, and the term was question mark, we're in a different branch of the decision tree, we'll go down credit poor, income high, and the term here, unknown, goes down the same as the 5-year loan, and again, we'll predict safe. In general, approaches that explicitly handle missing data in the algorithm itself can be quite helpful. They can help address missing data at training time and at prediction time, and can make more accurate predictions in general. And we just talked about an example in decision trees. The downside, though, is that it requires you to modify the actual learning algorithm to deal with missing data. In the case of decision trees, I'm going to describe kind of a very simple modification that can make this happen, but this can be very complex for other algorithms. And even for decision trees, if you want to make it really, really good, it might be more complex than what we're talking about next. But the idea here is fundamentally important, though.